Hello and welcome to today's webinar on deconstructing an attack in a containerized application. I'm Jacob Lukowitz, online editor at SD Times. Now before we get started, I have a couple of quick housekeeping announcements. First, the webinar will be recorded and available on demand through the sdtimes.com website in about 24 hours after the event. Secondly, if at any time you have questions about or during the presentation, you may submit them using the Control Panel's Question tab. At SD Times, we've been covering the importance of organizations reducing their attack surface, as last year has seen some of the biggest data breaches of all time. Today, during the webinar, a full-stack attack in a containerized application will be demonstrated and deconstructed from the app layer, EC2 layer, to the cloud management console. Then, we'll move on to how you can proactively identify the risk and provide guidance for developers. Here to discuss this further is Tim Buntel, the VP of Application Security Products at ThreatStack. Also joining us is Miguel de los Santos, the Senior Security Sales Engineer at ThreatStack. Now to get things started, I'll throw it over to you, Tim.
Okay, good afternoon, good morning, good evening, depending on where you're joining us from. Thanks so much for joining us today for a ThreatStack webinar called Deconstructing an Attack in a Containerized Application. Thrilled to have you with us today. My name's Tim Buntel. I look after the AppSec products business here at ThreatStack. And Miguel is joining me from the security sales engineering team. Miguel, say hello and tell us a little bit about yourself.
Hello, everyone. My name is Miguel, and I am the Senior Sales Engineer here at ThreatStack. Thank you, Tim, for the invitation for continuing our AppSec component in terms of our webinar.
Great. And so for folks who may not already be familiar with ThreatStack, I'm not going to talk too much about the platform up front, but I wanted to kind of quickly show this picture because it's something that we'll refer back to, I think, as we're talking about the episode that we're going to drill down into today. At its most basic form, a ThreatStack takes signals in from across an entire cloud stack, right? So we say full stack security observability, and we really mean it. We are pulling signals in everywhere from the cloud management console layer up through hosts and containers and orchestrators into applications. And then we're able to analyze the activity there to look for problems and bring them to your attention and help you respond to them. And so this puts us in a unique position to understand how do these attacks unfold across these environments. Typically you might hear from an application security vendor who can really understand what's happening in the application, but they're often ignorant about what's happening a little bit lower at the host tier. Or maybe someone looks at the cloud infrastructure as a service and looks at logs there, but they really have no idea about the application workloads that sit on top. But in reality, attackers view all of this as a whole. So ThreatStack has a unique vantage point to look at these types of attacks and see how all of the pieces fit together to put you in a better position potentially to prevent them. Now, one of the reasons we're able to see these examples and what we're drawing on today comes from our oversight and insight service. So ThreatStack, on behalf of customers, has an offering where we manage their environment and offer those services on behalf of customers. So we're 24/7 in our own dedicated SOC, performing these investigations and triaging and giving remediation guidance through our own ThreatStack experts. Each of the members are dedicated to work on behalf of the customers, but it also gives us a great opportunity to see what happens across customers. So we're looking at a number of different applications in a number of different environments, all running at the same time, and we're able to see these sorts of patterns and trends. And that's what we really want to build on today, because generally it's difficult to study real world attacks. Understandably, folks are reluctant to share too much detail if they get attacked, and if an attack is thwarted successfully, you might not even be aware that it almost happened, right? So one of the things that we are able to do by drawing on the SOC that we provide here at ThreatStack are these sets of observations that we make across our customers' environments. So that's what we're going to do today. We're going to look at a composite attack that's coming from a number of these actual real-world scenarios that our SOC observed on behalf of some of our customers. Now, a couple of months ago, we did a part 1 of this webinar, and we're going to expand on it this time. So if you didn't see that, don't worry. We're going to walk through the attack in a similar way. But we're going to add and enhance a couple of things. So if you did see that first one, I think you're still going to be learning some additional information here. Namely, we're going to spend a little bit more time at the application tier. We're going to see how you can detect runtime attacks as they're actually happening and step in to potentially block them, as well as really focus on Docker this time. So most of our customers now, whether they're building microservices or other cloud-native applications, are relying on Docker as a great way to quickly build and deploy those applications. So we want to put that front and center of the attack. But what you're going to see is basically what's outlined here is the way an actual attack unfurls as it comes from the application tier into the container and the orchestration tier, how that exposes access to the host that gives the attacker ultimately the opportunity to carry out some real damage down in the cloud management tier. So what we'll do first is we'll walk you through a successful attack, right? So we're going to kind of put on our attacker's hat and pretend that no one was paying attention to this, right? Going to be a typical application stack running in public cloud infrastructure, and we'll walk through how the attack would have unfurled if no one had been watching it. Then we'll rewind and we'll go through the exact same attempted attack, but this time we'll apply some of the controls that come from the threat stack platform that can give you the warnings and give you the opportunity to step in and prevent those attacks at each of those tiers from happening. Sound good? All right, so let's get started. So imagine your typical web application, public-facing web application, Node.js, a super common language and framework for building these applications. And the developer is going to take advantage of some capabilities of Node, in this case, the ability to execute code on the server. The eval function is pretty common for this, but it introduces some risk. And this may be present both in the native code that the application developer uses, or it might be in third-party components. The vast majority of application code deployed today comes from third-party components or dependencies of the dependencies even. So a single developer choosing to use one function, they may safely do it on their own, but unbeknownst to them, there might be unsafe uses of that functionality elsewhere in the application. So that's where our attack is going to start. It's going to start with a malicious actor taking advantage of one of these functions that passes input into the application that executes on the server. Then, once they're able to start executing code, well, that's where their ability to really start doing some damage comes into play. So, Miguel, why don't I turn it over to you and kind of walk us through, if I can start getting access to the back end and executing code, what are some of the things that I could potentially do in this containerized environment?
Most definitely. And particularly what we're concerned about here is the exposure that we allow ourselves, right, through that eval function. So hypothetically speaking, if we ran these simple commands from our own laptops, even here within the office, the output will be leveraging the metadata service in particular from this host to give me recognizance level data that allows me to pivot throughout the environment. And I think based from our previous conversations as well, and from the previous webinar, keep in mind that this can be done in general through AWS, Google. It doesn't really matter the cloud infrastructure. They all have some type of metadata service.
And is this specific to the fact that we're using a container architecture for the application?
It's actually completely agnostic to that. In this case, we are within a container, where in the previous webinar we were not. But as we said, it's completely agnostic to your container through Kubernetes, regardless of the infrastructure. As long as that 169.254 address is available, that's something that you could reach out to.
Right. So regardless of your public cloud provider, regardless of container technology, if you think that simply by checking that you have a secure container image, it's not going to protect you essentially from this type of attack.
Exactly, and I'd actually be more concerned about a container environment. Typically, you'd expect activity from the underlying host serving the containers, but in this case, how do you know what's actually being executed within?
Okay, great. So imagine now the attacker has access via the application tier. They can start to execute these kinds of commands. What are they able to get at with this?
Actually, it's a lot of data. So the examples that I have here are just a particular subset of very well-documented endpoints available to the container itself. And what you're seeing on the screen at the moment is the curl command invoking the instance security metadata from the specific container. In this case, I'm providing the access ID and also the secret key. Then I could, as a malicious actor, I could grab those two components and configure my own CLI to reach out to the infrastructure and actually do very terrible things.
Okay. And so is this really because of Docker? Is it because of AWS or something else? Because it looks like this is using the host in the Docker container to get information about the instance in AWS. Is that right?
It really depends on how the application for your specific organization has been developed. In reality, this specific service, in this case with the metadata service, is available to the underlying container, to the host, to the Kubernetes cluster to leverage, to just tell more information about it. But with more information comes more responsibility, right?
Okay. So now that the attacker has been able to access this metadata, they're going to take advantage of that metadata service for the next step of the attack, right? So what are we seeing here?
Right, because it's always building. So at this case, not only was I able to retrieve general instance information, but now I'm able to describe the volumes attached to the instance. Keep in mind that in a Docker environment and even a Kubernetes environment, you're sharing the underlying infrastructure from the host to the rest of your containers. So hypothetically speaking, if I were to gain access to that volume itself, I'm getting access to a complete file structure across all of your containers.
All right, so then we've now gotten this information. We're leveraging the AWS CLI, which obviously we know is powerful for developers, but can really expose quite a significant amount of risk. This is installed on every Amazon Linux image by default, right? So now that we're armed with this information from the metadata service, plus we have this access via the CLI, how does the attack proceed from here?
If I were to do this, it's really simple. The reality is I can copy the volume and make a snapshot of it, and from there I can gain access to that snapshot by forcing my ownership from my own AWS account. And the interesting thing is EBS is an encrypted volume when created. So it's just the fact that I'm being able to modify those from a snapshot that I created. It's just really concerning.
And from AWS's perspective, this doesn't set off any red flags. This looks like just like normal activity. Is that right?
That's 100% true. Not only is this normal activity, again, it's pretty well documented, and on top of that, there's CloudTrail events that are tied to EBS volume usage.
Yeah. All right. So, kind of scary.
Yeah.
Right. So here we've gone from a simple function that has legitimate uses in Node.js that wasn't even written by the developer, that was in a third-party library, that now allowed this attacker to come in and really, step through each layer of that full cloud stack, all the way down to the point where you're really getting to data exfiltration.
Exactly.
All right. So if that's the bad scenario, let's step back and say, okay, go through each of the steps of that same attack one at a time, and let's look for where, by exposing this idea of full stack security observability, where we're taking signals in from all of those tiers, we can have these opportunities to detect what's going on, and then apply rules or alerts or other actions that can be taken that could potentially certainly could alert someone that this was happening, and in some cases even stop it, right? So back up to the top, let's start with the application tier. So again, we saw that the developer was doing what he or she thought was right, using a function of part of JavaScript naturally. But there should be an opportunity here to point out to the developer that that might be a risky type of functionality to use. So how would we go about doing that with what we call proactive code review? So that's our application security monitoring solution. So what application security monitoring does is it allows the developer to very easily instrument their code with a native library. It looks like just any other third-party application library. But that will observe the running application and look at the functions that it's using, send that information back to the threat stack platform so that we can point out to the developer if they might be doing something that's risky. So could you show us that in the application?
Sure.
Great. So what I think we're seeing here is that it's pointing out to the developer that that particular function is being invoked. It's giving the developer the information they need to know where to go and potentially remedy it or change that functionality. And we're even showing them whether that's in their own code or in a third-party module, because I think the workflow for remediation of that issue would be different, right? If it's their own code versus if it's an open source project that they have to open a pull request to reduce that risk, right? Great. So let's go back, and hopefully this should stop it, right? So if we're lucky, the developer goes in, they realize they should consider another way of either sanitizing that input or maybe using a different function altogether that has a little bit less risk. But let's imagine for a minute that it didn't happen, right? Maybe the developer had other things to do or it got through testing. If that function gets released into production, we still have a second opportunity to look at the running application, right? So this is the runtime portion where ThreatStack is able to look at so we're looking at the traffic that's coming into the application, is that right?
That's accurate there, Tim. So what you're seeing here is a representation of remote command execution, right? Or an injection, depending on what's occurring. But the AppSec side is literally monitoring the payload to understand what's happening and then compare it and highlight that for you as well.
So in this case, we're not going to point out to the developer the line number or the module name in their code. We're going to look at how is the attack being carried out. Is that right?
Exactly. And the key piece here is information, right? Because at the end of the day, that eval function is allowing somebody to ultimately piggyback on its privileges to execute things into the host or the container. But here, what we're seeing is that runtime activity, not only capturing and showing you exactly what that command execution is, but it's also linking you to the underlying host within the ThreatStack platform.
Okay, great. So, and I would presume since we're running in the application as part of that request, as that process, the self-protect portion here could kick in, and how would that block this attack?
So in terms of the AppSec, since you can automatically block this particular activity, what it would do is it would stop the child process from actually allowing that execution
from
to
the
occur.
request altogether, right? So again, even if the developer kind of didn't address the risk in the software, even if the attacker found out a way to access this, sent some content in a payload to invoke that functionality, by detecting it, that could be blocked. And that could be for SQL injection, that could be for cross-site scripting or other types of runtime vulnerabilities. Okay, great. Well, that's kind of the application tier. But again, let's imagine, for the sake of argument here, that this wasn't running, and for some reason the application, we didn't instrument the application, it was just running in its normal form, and that payload was able to break through the application tier, and the attacker was able to carry on into the application. So walk us through where they'd go now, the runtime part of the stack.
Right, and at this point, right, moving outside of the layer, this particular application is within a containerized environment. And again, keep in mind that this could be Kubernetes, doesn't really matter there. But for the runtime with ThreatStack, essentially what we're going to see is that netcat execution being done, and then we're going to capture it based on our own library of anomalous activity that typically isn't run on a host. Obviously, within a Docker container, it's very rarely where you would see somebody trying to open up a listening port on port 80, for example. Now, jumping into the platform a little bit here. Now, let's go ahead and demonstrate what that would look like if I were to curl that process, and then as well as that netcat activity. So from here, I'm easily able to demonstrate exactly what Tim talked about, but we're not stopping the payload just for the sake of the example here. Let's go ahead and take it into a step further. What I'm more concerned about, not only that the netcat activity was executed, but on top of that was that somebody could essentially start a reverse netcat session with that open shell, allowing that activity to occur. And that's where the rest of the full stack observability comes in, where we pinpoint what's happening in the underlying layer with the threat stack agent that's running alongside your fleet of containers. And what we're seeing on the screen at the moment is actually that reverse netcat session. If we think about a containerized environment, I do care that the containerized event occurred, right? And that the netcat session is open on port 80 to everyone. But particularly what concerns me is the fact that as I traverse the attack, I do see activity after that, right? And if I look at the source IP, it's actually listing from an IP that looks like to be a private IP, public-private CIDR block available to anyone. Now, as I pivot through the platform, what I can then do is try to understand what's exactly happening within the container. So by leveraging what we call event search here at ThreatStack, we can get a little bit deeper data with what we call the event JSON to understand the actual container ID and the container image. And in a Kubernetes environment, we would include pod name and pod UID. But that specificity allows us to really dig into the data regardless of the ephemeral nature of the environment.
Great. So once we observe that, so then what do we do? So how does that feed into the rest of the process? How does either the SOC respond or other folks who are responsible for keeping an eye on this?
And at ThreatStack, it's all about flexible consumption, right? And the reality is that we don't expect you to live within the UI. You can integrate into Slack, PagerDuty, VectorOps, and the goal is to really streamline and eliminate silos where we can. And you would just typically see a change like this, right? Where somebody tried to make that modification with the previous commands that were presented in the webinar. And from here, by clicking that link, it allows me to really understand the specific activity, and then using the different key value pairs, I could leverage the platform to search through or look at the other severity ones that are triggered. But in this case, we're observing that metadata curl command that you saw previous being executed against that host. Now, moving further down to a different, same layer, but different data point, which is file integrity monitoring. The platform does allow you to fully manage your files and directories and really instantiate the lifecycle of those files and directories. And that's going to be particularly important for folks on the webinar today that really care about compliance. Now, by looking at that activity, we can definitely break down only through metadata who's accessing the file and the lifecycle of that file, and maybe even pivot through process IDs and different other key value pairs to understand what's happening from container to container with the underlying file system.
And this is where we're able to see activity against those configuration files that we saw leveraged in the initial attack, right?
Exactly. And if we think about folks who are using things like COPS or native Kubernetes versus a managed cluster like an EKS, this is going to really work towards their benefit, because understanding what's happening on things like etcd and those different configuration files that could really be hurtful for your whole cluster of Kubernetes worker nodes and underlying pods.
Great. So finally, then we arrive kind of at the bottom of the stack, the foundation layer, right? So once the attacker had access to those credentials and was able to use the CLI to start performing some of these unauthorized behaviors on the different on the EBS volumes, for example, that's leveraging information that's coming in from AWS and the Cloud Management Console. So how could we start to watch for that activity? What would we be looking for, and how would you set that up in the platform?
So out of the box, we actually have immediate detection for those items that we've talked about thus far. So ELB changes is something pretty consistent. But the key determinant factor there is who's copying it, what ARN role they're using, so on and so forth, right? It's really telling the story of the user activity throughout the whole entire attack. So what you might find, as I mentioned in that breakdown earlier, if I'm copying an EBS volume to my own account, I will definitely see the account ID, the username, and different key value pairs that allow me to compile that story without having to dig that out myself, just simply put via the alert that you see here. And you can customize this to be more of a higher severity depending on how ephemeral your environment is or how the infrastructure is constructed.
All right, so I think we saw how during the attack, the attacker was able to basically travel from tier to tier, from the application down into the Docker container, access host information and credentials that gave them access to AWS via the CLI to carry out the attack. So basically following that same architecture, it looks like, is what the approach here for how we could identify and potentially stop that attack, right? So we've got this notion of proactively looking for risk that might be present in the application and address it before the app even goes live. We have the notion of watching a running application when it is live for these telltale signs that might be in the payload, the request payload, that someone is trying to take advantage of one of these risky functions to do some remote command injection or remote command execution. Then we can take a look down into the runtime layer to look at processes that are running. We can see how those might impact files, reads of files or copies of files or moving of files. And then finally, if the person is then going to try to carry out some activity within the actual infrastructure as a service at the AWS layer, we can monitor for that activity there. Does that kind of sum it up pretty well?
And Tim, I would like to add that everything that we've walked through today is a simulated attack based on data that we've gathered from our SOC team, and for folks on the webinar, that application that we're using at the moment, Prone, is actually freely available in ThreatStack's GitHub. We are planning to do a following bit to this webinar with a blog post that's going to detail the commands as well. So feel free to reach out, create an account, and be happy to do a demo for you. And if you guys want a deeper dive into the application or demonstration, feel free to fill out a form with us at ThreatStack.
And again, I think we've kind of we've come full circle now, right? So I wanted to just finish on this image. Again, this can look really complex, and we know that modern cloud-native architecture and infrastructure can be really complicated, and folks tend to specialize. Either you're a container security person, or you're an infrastructure security person, or an AppSec person, but attackers just don't think that way, and they don't see those lines that vendors tend to put in between those tiers. So, in order to really protect yourself from these types of attacks, you have to be able to connect the dots really between all of these different tiers. So I think definitely in our experience, watching these kinds of attacks coming out of containerized environments through our own co-managed service in the SOC, and on behalf of our customers, we really are able to do that pretty effectively. And I really like what you've done here too, Miguel, in taking this application and bundling it up in a Docker container that customers can go or folks can go and download that and go through these exact steps of carrying out how an attacker might take advantage of this and be able to see how the platform responds to it. Great. Well, with that, I want to thank everyone for taking the time to join us today. We look forward to hearing from you. Come to threatstack.com, fill out a contact us form, or request a demo there. We'd be happy to drill into more detail on this specific scenario or whatever might be appropriate based on your own environment. Thanks so much.
Thank you.
Okay, great. Thank you both for a great presentation. Again, that was Tim Buntel, the VP of Application Security Products at ThreatStack, and Miguel de los Santos, the Senior Security Sales Engineer at ThreatStack. I'd also like to thank ThreatStack for sponsoring today's webinar, as well as the attendees for joining us today. Until next time, I'm Jacob Lukowitz.